Welcome to The Explainer. All right, today we are tackling a question that is so fundamental it shapes how we understand reality itself. We're talking about the difference between the stuff we can touch and, well, the stuff we can't.
Think about it. We talk about things we can't see or touch all the time, but have you ever really stopped to ask what they are? I mean, what does democracy actually weigh? Where is motherhood located on a map? What even are numbers? These questions might sound a little weird, right? But they point to a massive philosophical puzzle.
You see, philosophers try to sort everything that exists into two big buckets. In one bucket, you've got concrete things, rocks, trees, us, the physical stuff. In the other bucket, you've got abstract things, numbers, the concept of justice, ideas like that. Seems simple enough. But that clean separation gets messy fast. Where do you put the game of chess? Or a scientific theory? Or heck, a fictional character like Bilbo Baggins?
And that uncertainty, well, that's where the real fireworks begin. It opens up this huge philosophical showdown that's been going on for centuries. You've got two main camps, and they're locked in a debate over a really basic question. Do abstract things actually exist at all? So the whole fight really boils down to this. On one side, you've got the Platonists. They say, yes, absolutely. Abstract things like numbers are real. They exist out there, totally independent of our minds. But then the nominalists come back swinging, saying no way. The only things that are real are the things you can kick. All this abstract talk is just a useful set of labels we invented.
Okay, so we've got our two teams. But here's where the real problem kicks in. It's one thing to point at a rock and say concrete and think of a number and say abstract. That's easy. It's a whole other thing to try and write one clear, universal rule that cleanly separates the two categories.
And here's the kicker, the really surprising part. For a distinction that seems so basic to how we think, nobody can actually agree on the definition. Seriously. Creating a single rule that works for everything, from the number pi to Sherlock Holmes, has proven to be unbelievably difficult.
The philosopher David Lewis nailed this problem with a fantastic analogy. He said trying to define abstract by just giving examples is like saying that snakes are the animals we fear the most. Okay, maybe that's true. But it tells you absolutely nothing about the biology of a snake. It doesn't get to the heart of what a snake actually is. And that's exactly the issue here.
So, how have philosophers tried to crack this nut? Well, the most common approach is something called the way of negation. And the idea is pretty clever, really. Instead of defining abstract objects by what they are, let's try defining them by what they lack.
This whole approach basically gives us two simple tests. An object is abstract if, first, it's non-spatial. It doesn't have a location. And second, it's causally inefficacious. It can't make things happen. So concrete things exist somewhere and can do stuff. Abstract things are nowhere and do nothing. Seems pretty clean, right? Let's put this to the test. Take a rock. It's got a location. You can point to it and say, it's right there. Now try to do that with the number 5. Where is the number 5? The question doesn't even make sense, does it? It's just not a where kind of thing. And it's the same thing for causality. That rock can break a window. It has a direct physical effect on the world. But the number 5 itself, it's causally inert. It can't push you over, or hold a door open, or, well, anything in the physical world. But here comes the catch. What about those tricky cases we talked about earlier? Think about the game of chess. It was invented at a certain time, so it seems to have a place in history. And it definitely affects people's actions. That sounds a lot like causality. And yet, you can't hold the game of chess in your hand. This is where that nice, neat definition starts to look a little leaky. Okay, so that first attempt wasn't perfect. Let's look at another approach. Instead of defining abstract objects by what they're missing, this method, the way of abstraction, tries to define them by how they actually come into being. Now this sounds super complicated, but I promise the idea behind it is actually pretty simple. It's something we all do without even thinking about it. We create an abstract concept just by noticing that a bunch of different concrete things all share some specific property. So here's how it works. You start by observing something concrete. Let's say you see two lines, A and B, and you notice they are parallel. That relationship, is parallel to, is the key. From that shared property, we can abstract, or pull out, a brand new object, their shared direction. The direction itself isn't a physical thing. It's the abstract idea that all these parallel lines have in common. It's a really clever solution for some things, but it falls apart pretty quickly. How would you define, say, the English language using this method? Or what about pure mathematical sets? This model just doesn't cover all the bases, and frankly, it feels like it's describing more about how our minds work than what the objects themselves fundamentally are. So after going through all these major attempts to draw a clean line, where does that leave us? Well, we're left without a single perfect answer. This really is one of philosophy's great unsolved puzzles.
So let's just do a quick recap. We know this abstract versus concrete distinction is absolutely fundamental, and yet there is no universally accepted definition. The way of negation, defining things by what they're not, is the most common approach, but it has some serious flaws. And the way of abstraction gives us some neat insights, but it just isn't comprehensive enough.
Now you might be sitting there thinking, okay, this is interesting, but why does it actually matter? Well, it matters a ton. This debate has huge implications. How can we have objective knowledge in mathematics if numbers aren't real in some way? What exactly is a scientific theory like general relativity if you can't touch it? This whole thing goes right to the heart of how we justify what we know.
So ultimately, the search for that perfect definition continues, and it leaves us with a really fascinating question to think about. If the line between the physical world we can touch and the world of ideas we can't is this blurry, does that make our abstract concepts any less real? We build our entire lives with concrete things, but we understand our world through abstract ones. The fact that we can't draw a perfect line between them really forces us to think about the true nature of that invisible reality we all rely on every single day.